Hi, it's
You
Mr.
find our
Anderson, and welcome to
stage? I
Biology
don't believe
Essentials
you.
video number
I don't
36.
right
This
there,
is on the evolutionary
people.
significance
Right
of
there,
cell
welcome back to
communication.
Emily and
In other
Alice
words,
like this.
how cells
Oh,
talk to
right
one
there.
another.
I'm
And so,
having
I want to
This
start with
is
one of my
emotion
favorite
super
stories of
cat sister.
symbiosis.
There's
Symbiosis is when two
remaining
creatures are
doors.
living together.
Stay
And the
safe.
examples
Do
I have
not
here are
panic.
Vibrio fischeri,
They're
which is a
allowed you right
bacteria
there.
that can bioluminesce. In
I'll
other
call
words,
it
it
right
can
there.
glow.
This is
And
a
then this is the bobtail
1900.
squid, the
That's
Hawaiian
how
bobtail
the
squid.
what?
And what the bobtail
I
squid
heard
can
it.
do
I think alone
is
here
it can
has some place here.
actually bioluminesce
What
as
the
well,
hell
so it can
is
glow.
wrong with you?
But the
What
reason
kind
it
of
can
volume in the
bioluminesce is
CD
because
play?
it has
When is it real here? No,
these
it's not.
bacteria living inside
shoot.
it. And the
I
reason
think
it can
alone right
bioluminesce is
there.
if you're a
Remember,
fish
come
looking at
after
the
me.
bobtail squid from
Maybe
below,
be
they
alone
can
right
adjust
there.
the
You're
light so they
over.
actually blend in with the sky. And so
No,
they're both
definitely
getting
not.
something out of
There's
this relationship. In other
a
words, the bobtail
enough.
the
I
bobtail
have a
squid
lover
is
place
feeding
here.
these bacteria,
Shut
these
the
little
minute.
packets of
Here a lover place here.
polysaccharides that
I
they
don't
actually
below
feed the
here, right
bacteria
here.
food,
I
and in
can't
return they give
believe.
them the place to live. And so cell communication
What's the meaning of
is going to have
place
different
here?
roles
Of
depending
course
on
you
if you
don't.
are single cell
right there
or
here.
multicellular.
What's
So
happening
if you're
wrong
single
with you?
cell,
What are you
you have to
following
have
the CD
communication between
place?
all
We
these
find a colon
bacteria.
Trap
You
my
have to be
everyone.
able to sense your environment, and you have to be able to
check this
communicate.
out.
If you're multicellular, then all the cells in the organism have to be able to communicate and make sure that they're on the same page. And so we find that the same signals that are found in bacteria are very similar to the signals that are found in eukaryotes.
We don't blow here.
And so in this video, I'm really just going to talk about two things. And that is how communication through signal transduction pathways is conserved through evolution. And so in single-celled organisms, it's a response to the environment. Example I'll talk about is quorum sensing, and so how bacteria can tell other bacteria how crowded it is. And then I'll talk about multicellular organisms, how they can coordinate all their activities. The example I'll give you is how epinephrine is linked to glycogen breakdown, release of glucose. And so even though these are two separate pathways, the pathway of the single cell, the pathway of the multicellular organism, we find that the signal transduction pathways, how they work, how they operate, are almost identical. And so that means that they've been around a long time. They've just been co-opted for different uses.
What do you mean?
And so let's start with the Vibrio fischeri, which is a type of bacteria. They have two different ways they could live. In the ocean, if you are Vibrio fischeri living by yourself, planktonically, one bacteria by itself, we find that they don't glow. In other words, there's Vibrio fischeri everywhere in the ocean. They're all alone. They don't glow. It's just dark.
Come on, kids.
But if they live in a colony, if they live together and their numbers start to get large, then they'll start to glow. And so in this bobtail squid, they'll actually live just in this eye pouch right here. And once you get enough of them in that eye pouch, then they'll actually start to glow. And so how do they do that? How do they control that? Well, they use the signal transduction pathway. And so let's say this is one bacteria. So this is one bacteria. And it's all by itself, but it'll still be giving off proteins called autoinducers. And so since it's one bacteria by itself, and these are going to move just through diffusion, the odds of that hitting another bacteria are really low. But let's say we add more bacteria. And let's say we had more bacteria and more autoinducers, and then we had more bacteria and more autoinducers. Eventually what's going to happen is that those autoinducers are going to be picked up by other bacteria. That's going to set up a signal transduction pathway. In other words, a series of chemical reactions that cause them to do something. In this case, they cause them to produce a protein. In other words, they're going to transcribe a gene and actually make a protein. And if we're talking about this glowing bacteria, it'll actually make a protein called luciferase. Luciferase, and you can always tell if it ends in ASE, it's an enzyme.
Right there.
Luciferase is an enzyme. It breaks down luciferin, and it makes this glow. And it's an example of where you'd see that is if you've ever seen a firefly, it's the same enzyme. Luciferase breaking down luciferin, and it's actually making that glow. That luciferase will blend, or excuse me, will move through diffusion. It triggers this cascade, so this would be a positive effect or a positive feedback loop. And now all the bacteria are going to glow. Now let's say our numbers start to drop off. We're going to have less autoinducers. Less luciferase, we're not going to have that glowing. And so quorum sensing is a quick way for bacteria to see how many bacteria are there around, but they can also see, they can sense motion, they can sense chemistry, and the more we learn about bacteria, the more we're starting to realize that their communication between bacteria is really sophisticated. It's just as sophisticated as the communication we would have in eukaryotes.
You two don't have to
what are the constraints in eukaryotes? In eukaryotes, we have to get a message out, and we have to get all of our cells to operate together.
We have our
the best system inside our body that explains this would be the endocrine system. And so one of the best glands that we have sits right on top of the kidneys. It's called the adrenal gland. And in the center of that, you have what's called the adrenal medulla. And so that's going to get a message that comes from the brain, and that's called the fight or flight response. That fight or flight is going to cause the cells in the adrenal gland to secrete
now, hang on, everybody. Now we have
this looks a lot like the autoinducers that were secreted by the bacteria, and they do the same thing. That epinephrine is going to set up a signal transduction pathway in all the cells. And so remember, fight or flight response is when there's danger, and then you have to respond to that. Example is you have to get a bunch of blood sugar so we can start making ATP so we can respond. And so by releasing all that epinephrine, it sets up a signal transduction pathway. In other words, a cascade of events inside the cell. And I'll talk more about how it uses cyclic AMP, but what it eventually does is cause transcription of messenger RNA, the creation of an enzyme, in this case it's phosphatase, and then the breakdown of glycogen to create glucose. Now we're looking inside the cell, and we're seeing how this addition of just this one chemical message, this one epinephrine, can set up the signal transduction pathway to create a bunch of glucose. This could be luciferase as well that was created in those bacteria. In other words, we use communication to sync single-celled organisms with their environment and coordinate activities in eukaryotic cells. And so that cell communication, again, found in all organisms. We're just getting to unlock some of its secrets inside. I hope that's helpful.